right, so today we're going to be talking about triangles. We are on page 332 in our math books. These pictures that I've got in our math notebook are the exact same pictures that are on, similar anyway, to the pictures that are on page 332 in your book as well. So the first thing we're going to talk about is triangles based on sides. And there's three different types of triangles based on sides. The first one that we have is called scalene. Scalene, that's kind of a weird name there. Scalene triangle. And a scalene triangle means all three sides of the triangle are different. If you measured the length of those, none of them would be the same. So no sides are congruent. We talked about congruent yesterday, and congruent means exactly the same. And in a scalene triangle, there are no congruent sides, so every single length is different. If you look at the picture of this triangle, it's kind of hard to see since it's a gray triangle, but this one has a 1 dash, this one has 2 dashes, this one has 3 dashes. So it's visually showing you that all three of those sides are different as well. So that's one thing. Sometimes when you have visuals like that, you can easily see whether or not the triangles have different side lengths or not. So scalene, all lengths are different. If we look at the second type based on sides, it's called isosceles. Isosceles triangle means two of the sides are equal and the third side has a different length. So two of the sides are congruent, one side is different. If you look on this triangle, there are 2 hashtags on this side, 2 hashtags on this side, so you already know that those two have the same length since they both have the same markings on it. There's no marking on the bottom one, doesn't match. Isosceles triangle, the length of the two sides are equal. The last triangle that we have is an equilateral triangle, and it even has like the word equal in it. Equilateral triangles, the length of all sides are equal. All three sides have the exact same length, which is why it's called equilateral. So all three sides are congruent. And if you look at this picture here, they've got indicators on each side that match. Now sometimes pictures aren't going to have those, and so you can't always base it on those as far as that goes. So you might have to do some measuring with these to decide if all sides are equal or different in this case. So 3 ways to base a triangle on a side. If all sides are different, scalene. If 2 sides are the same, isosceles. If all 3 sides are the same, equilateral. Another way that we look at triangles when we're looking at triangles is based on the angles. So we look at them both based on both sides and angles. So if we look at the first one, it's called an acute triangle. Well, that goes back to the same thing we just talked about with angles. Every angle in this triangle is smaller than 90 degrees. It's a small angle, so it's called an acute triangle. All 3 angles are acute. If we look at a right triangle, it has one angle that is 90 degrees. Not all of them can't be 90 degrees, but one of them is. And in this case, they even gave you the picture, the indicator that shows you it's a right angle. And you can see the perfect L there, which we know indicates a right angle. And that one's called a right triangle. And then finally we have an obtuse triangle, because it has one angle that is bigger than 90 degrees. One angle is large, the other 2 are small, but one of them is obtuse, which makes it an obtuse triangle. So obtuse triangle, one angle is bigger than 90 degrees. Right triangle, one angle is exactly 90 degrees. And acute triangle, all 3 angles are smaller than 90 degrees. So we have different ways to classify triangles by their sides and by their angles. And you'll be doing that in your assignment today, where you have to classify them by their sides and by their angles. Now, the other thing with triangles is no matter what size the triangle is, whether it's a really large triangle or a really small triangle, when you add up the 3 angles, this angle, this angle, this angle, or if we went to our acute triangle, this angle, this angle, this angle, Anytime you add up all angles of a triangle, they always equal 180 degrees, no matter what. Doesn't matter if it's a giant triangle or a teeny tiny triangle. They always equal 180 degrees. So when we're looking for angles of a triangle, if we don't have all the angles, we can figure out angles based on that knowledge. It doesn't matter if it's an acute triangle, a right triangle, or a obtuse triangle. They're always going to equal 180 degrees. So if we take a look at how we're going to solve that today, and I'll have you guys work on this on your homework because it's the easiest way to do it. If we do angle plus angle plus angle, it's always going to equal 180 degrees. Always. Never going to change on triangles. Angle plus angle plus angle always has to equal 180 degrees. So if we look at this triangle here, for instance, that I have in our notes, we can see this top angle is 45 degrees. There's no measurement here, but I see that box there, so I automatically know that that's 90 degrees. So I have two of my angles, and I don't know what this angle is. It's a question mark. We got to figure it out. So how we're going to do that is we're going to plug in our numbers. What do we have? What do we know? So I know that I have 45 degrees plus 90 degrees and plus a question mark. I don't know. But I know that it has to equal 180 degrees. I already know that. So I'm going to take the angles that I do have and I'm going to figure it out. I'm going to figure out how can I figure out what am I missing. So the first thing we're going to do, step one, we're going to add 45 plus 90. Let's add up and see what we do have. So in step one, I've added 45 plus 90 and I have 135 degrees. So I know when I added my 90 degree angle and my 45 degree angle, I have 135. Now, I know when I add this third angle, it has to equal 180. It can't equal anything else. So in step two, I'm going to take 180 and I'm going to subtract 135. This is what I know it has to equal. I already know that. This is what I already have. So I'm going to subtract them and figure out what I'm missing. So I know the missing angle here is also 45 degrees. Angle plus angle plus angle is always going to equal 180. That's a right triangle. It doesn't matter if it's an acute triangle, if it's an obtuse angle. Every single time we add it up, I know that it's going to equal 180 degrees. 180 degrees the whole time. All right, so let's take a look at another example here. If I had this triangle here and I needed to know what's the missing angle. I have a 35 degree angle at the top, I've got a 65 degree angle, and I need to figure it out. Well, the first thing I'm going to put is angle plus angle plus angle equals, I already know the answer. I already know what the answer is. It's 180 degrees. Now I'm going to fill in what I have. Well, I know I have 35 degrees in my first angle, so I'm going to put a 35 there. I know I have 65 degrees in my second angle, so I'm going to put a 65 there. And I don't know what that missing angle is. So I know it has to equal 180. So on my first step, step one, I know I have to add up what I already have. So I'm going to add 35 plus 65. When I add that up, 5 plus 5 is 10, 6 plus 3 is 9. I have 100 when I add those two up. Well, I know that my total has to equal 180. So step two, I need to take my 180, that's my answer, and I'm going to subtract what I already have. And that leaves me with 80. So I know that my missing angle is going to be 80 degrees. I know my missing angle is going to be 80 degrees. It doesn't matter what kind of triangle you have. If we'll do one more of these, because you're going to have to do these today, and I'm going to draw an obtuse triangle. Okay, so if we look at my obtuse angle triangle here, I have one angle that's 105 degrees. I have one angle that's 35 degrees. And I know that when I add my third angle here, it's got to equal 180 degrees. So we're going to start with how we're always going to start. Angle plus angle plus angle equals 180. That's never going to change. Angle plus angle plus angle equals 180. Doesn't matter if it's a giant triangle the size of your room. Doesn't matter if it's a teeny tiny triangle the size of your palm. Always going to equal 180. We're going to fill in the angles we have. We know the first angle is 35. I know the second angle is 105. I don't know the third angle, but I'm going to figure it out. Step one, what do we have to do for step one? What did I say we had to do first? Step one, we're going to add 105 and 35. That's going to be the first thing I do. 5 plus 5 is 10. Carry 1. I have 140 so far. I know that I have to have 180. Step 2, I'm going to take my total. I already know what it has to be. And I'm going to subtract what I already have to figure out my missing angle. And there it is. I know my missing angle is 40 degrees. Angle plus angle plus angle, always going to equal 180 degrees. All right, so let's take a look at your homework today. If you look at page 332 in your math book, page 332, we're going to start there. The first thing you have to do on the first part on 1 through 8 is you have to classify each triangle as scalene, isosceles, equilateral. Those are your three choices. That's going to be your answer. Scalene, isosceles, equilateral. So you're going to look at the picture. If it's three acute angles, you're going to write it, or I'm sorry, if it's two sides are the same, you're going to write isosceles. If three sides are the same, you're going to write equilateral. If none of the sides are the same, you're going to write scalene. I do notice on these, they do have hashtag indicators there for you. So you should be able to tell the difference between those. On the second part, starting with number 9 through 15, now you're going to classify them by their angles. So your answer choices are going to be acute, right, obtuse. Those are the only choices you have there. If it has a right angle, it's a right triangle. If it has 3 acute angles, 3 small angles, it's an acute triangle. If it only has one obtuse angle, that makes it an obtuse triangle. So you need to look at all 3 angles to decide, is it a right triangle, is it a acute triangle, or is it an obtuse triangle? So you're only going to write one word there, acute, right, obtuse. Now, if you look at the top of page 333, that's where we just talked about angle plus angle plus angle equals 180. You're going to do the same thing here. Starting with number 17, it gives you 3 measurements. It says, is it possible for each triangle to have the given angle measurements? Right, yes or no? Well, you're going to have to add up the angles. I noticed on 17, the angles are 70, 90, and 30. If you add those up and equal 180, well, yeah, that's possible. If you add those up and they don't equal 180, no, it's not possible. So you'll have to tell me, yes, it equaled 180, no, it equaled whatever number you came up with. So you'll have 2 answers there, yes and no first, and then tell me what your measurement was. Add them up. If it equals 180, it's a yes. If it doesn't equal 180, it's a no. Simple as that on 17, 18, 19, 20. On 21 through 24, you're going to find the missing angle just like I just showed you here. It's going to be the exact same thing as what we just did on the board work. 21, 22, 23, 24. They've given you 2 angles. You have to find the missing angle. You're going to set it up the same way. Angle plus angle plus angle equals 180. The first thing you're going to do is add up the 2 angles you do have. The second thing you're going to do is subtract 180 minus whatever you added for the 2 angles that you have. The difference is going to be what your measurement is. So 21, 22, 23, 24 are exactly like what we just did on our board work.